All right, so I guess we're ready. Our speaker today is Matthew Chang, and I'll let Matthew take over now.
All right. Hi, everybody. My name is Matthew Chang. I'm a teacher of computer science at Livingston High School out here in Livingston, New Jersey, and I teach AP Computer Science Principles. I think this year I have about 6 sections. Last year, I think I had 7 sections or so. So I actually go back to school tomorrow. So I have to pack my gear and get ready to go back to school in a few. I also teach at Kean University, where I teach game design and development. And I also teach a kind of equivalent course to AP Computer Science Principles called Computing in the Modern Society. So I feel very fortunate enough to be able to teach Roblox also at the college level. So I kind of tell people that I teach big kids how to make little kids games. So they find that a little bit amusing, which is going to lead us into our presentation for today with Roblox using AP Computer Science Principles. For the past 3 years or so, I've been a reader for the College Board for the AP Computer Science Principles course. So this past year, I did about 53 hours or so of reading. I think I went through like 150 submissions or something like that. I think I was feeling kind of dizzy after a while going through the performance tasks, which again, we'll kind of discuss in today's webinar. I have a Master's of Arts in teaching secondary education mathematics, and also a Master's of Science in Digital Forensics and Cybersecurity, which is a computer science specialty, and also a Bachelor's of Science in Computer Information Systems from William Patterson University and John Jay College of Criminal Justice. I got an invite, which I'm very excited about. I haven't attended the RDC since 2019, but in about 2 weeks, there's going to be another Roblox Developers Conference. So you might notice that there may be some new features rolling out in Roblox Studio. And we'll kind of give a tour tonight of some of the features in there. All right, so on today's agenda, we're going to take a look at AP Computer Science Principles. I'll give you kind of a broad overview if you're not familiar with that already. We'll look at the Create Performance task, which we're kind of building our curriculum towards. We'll look at what is Roblox. Brand new for what we've been working on throughout this summer is the PopViz AP Computer Science Principles Roblox curriculum. And lastly, we'll kind of end the session with playing a Computer Science Principles performance task game that I kind of hacked together based on the requirements of the performance task and also with the materials that we've written for the course. So just as kind of like a brief overview, Computer Science Principles is a relatively new AP course from the College Board, and it's meant to be an introductory college level computing course. So not necessarily your first semester computer science course, which is what the AP Computer Science A course is. This is kind of a general computing elective that students would have when they go to college. And again, if they receive a qualifying score on the AP exam, this would take its place. So this course is meant to be, as in the word principles, kind of like a breadth of the overall field of computer science. So not necessarily just all programming, but also like how the internet works and things like this. The form of assessments for this course is as follows. So there's a multiple choice part of the exam, which is about 70% of student scores. There's about 70 questions. It's about 2 hours long. And then there is something that's pretty unique to this particular course. There's not many APs that have a performance task. For this particular course, there's a Create Performance task, which is worth 30% of students' grades, and teachers are required to give students about 12 hours or at least 12 hours of class time specifically to work on this Create Performance task. So the criteria, which we'll go through in a few moments, are already kind of known to everybody, and that's kind of where teachers are working towards for the entire school year. So these are the AP scores for the reading that just took place a couple of weeks ago at this point for the last school year. So overall, this is probably one of the most popular AP courses in the country. About 122,000 students from around the world took this AP course, about 5,300 here in New Jersey. The mean score is about 2.88 globally. My mean score was about 3.24. New Jersey average is about 3. And then as far as passing goes, again, on the AP scale, which is 1, 2, 3, 4, and 5, anything above a 3 is considered passing. So about 78% of my students passed. Globally, about 62% of students passed. And that's probably where it's been for the existence of the computer science principles exam. Now, as a teacher, we also get a breakdown of each individual row and specifically each reporting category. So again, these are the big ideas with computer science principles. So we've got creative development, we've got data, we've got algorithms and programming, we've got computer systems and networks, and we've got impact of computing. Again, not all of these topics are very specific to programming. Again, with the principles course, we're also looking at other topics as well. So although my head is a little bit in the way here, I'll just kind of briefly go through here. You do have the number of questions for each particular topic. That helps with planning purposes, where you need to, as a teacher, where you need to know you need to concentrate. And if you look at the number of questions, algorithms and programming, also with data kind of related there, are probably the 2 highest number of questions that they'll see on the multiple choice part of the exam specifically. And then also you kind of can see the mean scores for each particular big idea here. So for example, here, algorithms and programming, my group, my students got about 14 out of 24 questions correct, and the global average was about 14. All right. Additionally, we also have computing practices. So again, some of these are related to programming specifically. And again, we've got the breakdown of the number of questions here. So we've got computational solution design, algorithms and program development, abstraction and program development, code analysis, and also computing innovations. So I would say, again, about half of them, again, are related to computer programming. And specifically, this is looking at the MCQ, the multiple choice part of the exam. Again, question types, we've got algorithms and program code. Again, further breakdowns over here. Now, the really interesting thing here is, again, looking at that 30% that create performance tasks, teachers also get a breakdown of each row. So in the performance test, there are 6 rows that students are graded on kind of a binary system. So it's either you get full credit, which is a 1, or you get no credit, which is a 0. So as an AP reader, literally, I'm just kind of like pressing like 0, 1 for each particular row or so. Now, this is now the 2nd year that we've used this revised rubric for the current iteration of the course exam description. And if you look really closely here, again, the max score here is 6, leading to that 30% there. So in other words, you kind of think of each row as about 5% of a student's grade. Global average for the performance task was about 2.7. This is, I think, from what I remember from the 2021 reading, a little bit higher. But again, if you think about it, this is 2.7 out of 6, which means that globally, the majority of students around the world did not actually pass the performance task. And I think that's kind of complicated, and I'll kind of go through that there. Again, we also get a row by row breakdown in terms of how students did. So even my students for row 1, which I'm not really sure if the College Board meant for students not to do well on this very specific row. This row is looking at the program purpose and function. Only about 50% of my students, as well as 50% of the students around the globe, actually got the first row correct. Now, I can also mention that as an AP reader, every year the reading, although the rubric is about the same, they did make some minor adjustments or so. Every year with the reading, the chief reader typically changes. And with the chief reader changing, there's usually a kind of slight differences in interpretation for each rows. So I'll kind of put that out there. And we'll kind of look at some responses to the rows when we kind of look at our game that I created. Row 2 is data abstraction, so that's a list. Most students got that correctly. So that's about 60% of people got that correctly around the globe. Managing complexity, which is, I think, a very technical question. It's asking how would you write the code differently if you didn't use the data structure specified in row 2? I think that's kind of a very high level, higher order, almost college level question about how you write the code differently if you didn't use that particular data structure. Now, this data structure requirement is, again, a new part of the current rubric for this course. So previously, students didn't necessarily have to know about data structure. So I think that's another hard part there. Row 4, 5, and 6 are a function, specifically with a parameter, and contained within the function, there's an algorithm which contains sequencing, selection, and iteration, which is a bit of a mouthful, but basically it means that inside of the function, you have a loop as well as a condition. And so again, row 4, only about, I think my head's kind of like in the way here. I'll look at the global average here. Only about 50% of students got row 4 correct, row 5, about 40%, and row 6, which is testing the function, again, globally, only about 40% of students got that correctly. So we'll take a look again with kind of like a sample program that I wrote specifically for the materials that we wrote, and I'll kind of like show you some sample responses there. So what is Roblox? So Roblox is an extremely popular game, I would say with the most popular game with elementary and middle school students or so. Roblox's mission is to connect 1 billion people together. And very interesting and unique to the Roblox platform is that Roblox is only providing the technology for the games. So all of the games are developed by just anyone who are just uploading their games via Roblox Studio into Roblox.com. So statistics wise, and these numbers are coming from Roblox, each day they've got about 52 million users who are playing their games. They somehow calculated this number here overall of about 4.7 billion hours of engagement. So those are people playing the games. 12 million different creators have uploaded games into the Roblox platform, and they've created about 32 million different experiences. So again, all of the games that you find on Roblox.com are just created by developers. Roblox doesn't actually make any of the games themselves. They're just providing the technology behind it, which we'll kind of look at in a few slides. So I was actually able to attend the RDC 2019. And this is a quote from the creator of Roblox, and it'll kind of lead into some classic computer science that I'll show in a few moments here. So he said, "We are bringing the world together through play." And I think that this is a really good way of getting students interested in computer science. And again, historically speaking, which we'll see in a few slides, they've been thinking about this idea since the last couple of decades or so. Now, what we've been working on very specifically is the PopViz AP Computer Science Roblox curriculum. And so sometime last year, Roblox came out with a community fund very specifically earmarked for education. And PopViz was a recipient of this. And so with that, we came out with our AP Computer Science curriculum. We submitted it to the College Board a few weeks ago for approval. So once it's approved, you can actually go ahead and submit that as part of your AP Computer Science Principles audit. Now, again, kind of historically speaking, kind of like the forefathers of computer science education. And you might have done this before. I kind of vaguely remember doing this as a kid. Something called Turtle Graphics, which is still used today. Turtle Graphics was part of the original Logo programming language developed by Wally Ferzig, Seymour Papert, and Cynthia Solomon in 1966, specifically to teach students to code. Papert wrote a book called Mindstorms, Children, Computers, and Powerful Ideas, where he described the turtle as an object to think with. So this name might sound familiar because it's actually the inspiration behind Lego's Mindstorms, which are robots. And kind of think of, when I look at this phrase here, the turtle is an object to think of. Again, I think about where we're kind of like coming from, and I show students like this picture here from way back in the 60s about kids learning computer science, and they look really happy. And I'm thinking to myself, that they're probably thinking that this is pretty cutting edge from back in the day, drawing these pictures with turtles. But we've come a little bit further than that, which I'll show you in a couple of slides here. So these are some of the commands that students would use using turtle, a logo, so kind of very rudimentary. We've got like forward, we've got right, we've got left, etc. Just trying to get students in the framework of thinking about how do I actually use this turtle to kind of like think and do commands. Now, on the AP exam, students face questions kind of a lot, very similar to that even today. So this is one of the sample questions from the AP exam. Again, the goal here is to get the robot, and this is the starting position over here, to the ending position, which is right over here. And the choices that they're presented with on the MCQ part of the exam are using loops to try to figure out which one of these solutions will get you from the starting points using this exact route here to the ending point. So inside of our curriculum, I kind of updated this a little bit. So I have, and this is like my closest avatar to a turtle. I came up with a dinosaur. So again, we have this starting location over here. I drew some arrows about the route that I wanted the ball, which is a part inside of Roblox Studio, to get to, kind of like the path that it would kind of take here. So that was my take on the robot turtle. Also within our curriculum, again, the emphasis here with computer science principles in the multiple choice part of the exam is to be able to, again, with programming, to kind of like trace through loops. So here, again, I have students kind of like tracing through, as I would with any programming language, how you would go from a loop, starting with, let's say, a stepper variable, having a condition, and just kind of like looping through until you finally got to the end and the condition is false. At which point then you'd have to change directions to get to the destination. Now, if you look very closely here, this is actually the code that you would see inside of Roblox Studio to turn the turtle, or in my case, it would be a ball, is a little bit more complicated. And I'll just kind of make my head disappear here for a moment here. So to change directions inside of Studio, we're actually dealing with 3 dimensions. So that's why we have a vector 3 with X, Y, and Z coordinates. Actually, there's another dimension, which is the camera angle. So actually, you're technically dealing with 4 dimensions here. But this is the programming that's behind it. Again, very classically speaking, we've got like a loop that loops, let's say, like 5 times. We're going in a very particular direction. So I kind of updated what students were previously doing, even way back in the 60s, to something I think that is kind of very visual for them to see and try to get through the maze. Now, the programming language behind Roblox Studio is a language called Lua. It's a scripting language, kind of similar to Python, I would say, if you look at it kind of like visual-wise. Developed in Brazil in 1993. Lua means moon in Portuguese. You can kind of look at more information about Lua at lua.org. Now, Roblox has heavily modified this language called Lua, and they have their own version of it called Luau, which is based on the 5.1 version of Lua. I think they're currently up to like 5.3 or 5.4 of Lua. But behind the scenes, Roblox has actually kind of rewritten the entire Lua programming language specifically to make it go faster, and then also add their own API information there. So officially speaking, they call their language Luau, but instead of our course here, I just kind of call it Lua. Both of them are being actively developed, but I think for simplicity's sake, I just kind of refer to language as Lua. So I'll just show you some code snippets in a few. Now, as we've mentioned before, I would highly kind of suggest after this webinar, or if you haven't already, download and install Roblox Studio. It's free. It is the same login password as when you create a Roblox account. And so you can kind of get a feel for things. And this is kind of a screenshot of the development environments. I happen to have it in dark mode. You can kind of switch that. There's like light mode. There's also dark mode here. So we've got an explorer the way that I've configured it is that I put it on the left-hand side. These are all objects, which I'll talk about in a few moments. You can look at the object's properties. Again, very classically speaking, we have an output window, which doesn't necessarily appear inside of a game, but it does, you can enable it for when you're programming, which is very useful. And also there's a command bar all the way at the very bottom as well that you can enable to see the output or type in commands very specifically. Now the Explorer displays all the objects in your game. And at the very top of the hierarchy, although you don't see it, it's an object called game that everything kind of emanates from. The workspace is the service which any of the objects that you introduce into your game exist. And again, with all of these objects, although we're not really doing object-oriented programming, when you take a look at the code, we are dealing with a lot of objects, but we're not necessarily coding in an object-oriented way. Kind of with all of these objects here, and you can kind of see with the notches, with the objects, all of them have parent and child relationships here. So I kind of like drew some diagrams to kind of visualize it for people to get used to this idea of parents and children. Again, workspace is the child of game, if you don't see. And again, within workspace, we've got all of these children. So we've got camera, terrain, spawn location, and base plate, which are all kind of the default objects with every game that you create. Now, just very quickly, camera is always included because you do have to be looking at the environment. The terrain, if it exists, is the game's environment. Spawn location is where you start the game. And also the base plate is that default texture. I usually use the kind of like a default grid, which makes it easy to develop with. So again, just kind of like as a hierarchy, I drew this picture here. We've got like game as the parents, the ultimate parents. And we've got workspace, which is a child, but which is also a parent as well, because it's the parent of children, terrain, spawn location. And again, even within spawn location, we also have decal. So you've got all of these kind of parent-children relationships with all the different objects there. Now, with each object, you can view their very particular properties when you kind of like click on it. So you can do this either through the GUI inside of Roblox Studio, or as we'll kind of look at with scripting, you can also change all of these properties via code. Now, the way to access these properties, you think of languages like Java, for instance, use a lot of dot notation very specifically to access properties and also to call functions as well sometimes. So just to show you an example of what the code looks like, this is like a very simple script here. So this script here is the equivalent of you, let's say, dragging a part from Roblox Studio and just dragging into your environment. This script here will actually create a ball. And again, I'm like setting its properties here. So I've got neon, I've got red, green, blue, and then I've got it setting the color of our ball to 255, 255, 255, which some of you will know. All right, now, again, some coding examples here, and I think this looks very similar to what students see on the MCQ part of the exam. This is an example of a Boolean variable. We've got if humanoid. This programming pattern is used a lot inside of Roblox programming, specifically because different objects interact with each other. And very specifically, you'll want to program for when, let's say, a humanoid interacts with an object. So here I've got, let's say, if humanoid, then you print only human, else not very human. And again, this is very similar to what students see on the MCQ part of the exam. This is also a very favorite question on the MCQ part of the exam. I feel the College Board writers are always obsessed with odd and even numbers. I try to explain this to students as, actually this comes in pretty handy depending on some of the coding that you're doing to, like, let's say, alternate things. So again, this is what it looks like inside of Lua. Now, I'll kind of mention here that if you're coming from a language like a classical programming language like C and C++ or Java, you kind of look at this and you're like, wait a minute, what's this like? What's this word then? And then you've got this word end here. And if you think about it, these programmers, and I think when I think about maybe perhaps why they did what they did. Although I also mentioned that to students that if you too want to create your own programming language, you can get people to code the way you want them to code. I think one of the reasons why the Brazilian programmers decide to go with specifically words here is because, they've replaced those symbols with very explicitly words instead. So that was conditional there. This slide here, usually I would say to students that you don't typically want to have an infinite loop. So we've got like while true here, but actually with coding inside of Roblox Studio, you can do really cool things like changing the C frame, which is also known as the coordinate frame. You can actually change that to make the coin spin, and you can make it spin actually not just on the x-axis, you can also make it spin on the x, y, and z axis, or you can make them all spin all at once, which is pretty cool. So again, this is like a while loop here. And again, like I would do this differently if I was teaching computer science principles through, let's say, like Python or so. Again, visually speaking, what we can do with Roblox Studio is that, let's say I have like a fire. I can have the size of the fire go from, let's say, 5, make it go down to 1, and then I have this conditional here within the loop. And when the value of the stepper variable gets to 0, I can actually turn off the fire. So again, this programming, I think, can be very visual for students, and I think that makes it more interactive and engaging for them. Now, this is a for loop, just to kind of give you a taste of what Lua looks like here. This, I think, looks like almost like a Python for loop. Third argument here is optional. So again, you just set it up here for I equal to 1, 5, 1 here. 1 is default. You don't necessarily have it, but you do have the option of going up or down by whatever value that you want. Now, again, visually speaking, what you can do with the for loop inside of Roblox Studio is that I actually created steps that were going up, and then again, using a for loop that was counting up. And then I had another for loop that was counting down to create these steps going down. So I think, again, Roblox Studio really lends itself to kind of programming in a way that students can kind of see something very visually with the coding that they would write. Now, nested for loops, again, part of the MCQ part of the exam here. The way that I've written the lesson on that is explaining that rather than repeat the loop code again and again, you could use another loop to repeat the loop. So let's say you have this like row here of like 10 different blocks. And let's say you want to make like a 10 by 10 grid. Then again, this is the way it's actually tested on MCQ. It'll ask you questions like, how many iterations will the nested for loop run for? So again, it's like you're counting outer times inner using multiplication. Now, to do something with that, again, I have my 10 blocks here once, and then I loop that 10 times. So now I've created this like 3-dimensional board of 10 by 10, and I have these like random colors here. So that's kind of a brief overview of like some of the simple coding concepts. Again, functions, I think, look very similar to functions that you'll find in any programming language. You've got keyword function, function name, parameters. You can specify the name of a part via parameter here. I have here, again, very similar stuff here. These are function calls with different arguments. Again, looking very similar to other programming languages. All right, now, as far as the performance test goes, I'm going to show you, I went through the requirements before. This is a flow chart that I give students to kind of wrap their head around after we've done all the topics for computer science principles. Again, at the end of the kind of like, I would say for my students, kind of like the end of March or so, after they've learned all the concepts that they need, I tell them like, hey, you've got to put it all together specifically to make one program that meets the requirements of the performance task. And this is kind of like a flow chart of all the different rows that I mentioned before. All right, so now we'll go ahead and we'll try to I'll jump into a game at the same time. So I have it up already here, and I'm going to click on this link and let's see how many people have Roblox Studio installed. All right, so my Roblox is like firing up here. Let's take a look. All right, let's see. So I'll wait a few moments for people to jump in the game with me. And I'll just kind of give you an overview here. Someone has to start the fire. I'll probably start the fire. I'll explain that in a few moments. And the object here, we've got a leaderboard up here, is to collect the marbles, but watch out for the fireballs because they will decrease your health. All right, we've got some people. Okay, here we go. I see people like spawning in. All right, so I'm jumping around. By the way, there are signs for where you need to go. I would go in the direction of the marbles. If you're like looking here, this is a proximity detector. So this is how like I'm starting the marble madness here. So I've started the fire now. Again, if you follow the signs, I'm going to go up the hill here. And as you can see, all these marbles are spawning at this location here. And your object is to get as many marbles as possible, while at the same time trying to avoid, every now and then you'll notice, and I'll show you like my code in a few moments, there's going to be like fireballs that appear. So do watch out for the fireballs. You don't want to touch the fireballs. You get hit by enough fireballs, your health will decrease, and they're kind of like spinning by like super fast. So I programmed that on purpose. So do be careful about that. All right, so let's see. Oh, I think I have the most so far. Let's see. Let's see, where is, oh, I'm seeing like these balls are like going super fast here. Where did my balls go? Oh, wait, I think some of them are coming. Where am I? Actually, I do have it at a certain point. We might have to like reload somebody may have to like go back to that fireplace and like start the balls shooting out again. But I think, wait, I think there's somebody at the top like hanging out. Somebody's actually someone's gotten the picture here of like how to get all the points. Look, it's my competition. I just ran past them. I wonder who that was. Ooh. But like I said, every now and then it's going to be a fireball, so it might come at you. So you might not always want to like be hanging out right at where I kind of like have that point of all the fireballs coming out, all the balls coming out. So I think my loop actually ended. In which case, to like keep going, somebody has to like start this again. So again, like this is like, I'm just going to shoot it like one more time. So that again is like the starting. And then if you go back up, there'll be more marbles shooting out of the mountain here. All right, here we go. Now I'll kind of like watch people like going around. All right. I see some people running around after my, oops. Oh, I see some people getting busy here. All right, so, okay, let me continue on with my presentation here. So I'll kind of show you behind the scenes here. So again, if you're interested, at the very top right-hand corner, if you're interested in looking at the source code, if you notice there's these triple dots, and that means that the source code for this experience is available. So if you click on it and you click on edit, it ideally should open up Roblox Studio with the code that I've written. Now, I was testing this out, and for some reason, like when I was testing this out earlier, for some reason that I don't really know, Studio was like throwing some error messages, but I did make this available. If you're interested in the source code, feel free to contact us and you can kind of like take a look at what I've coded there. Now, as far as the performance task goes, I just want to go over some of the requirements for the rows and talk about how students would answer the particular rows there. So again, row 1 is about purpose and functionality. Now, in one of the released answers for the performance task, for the purpose for a game specifically, it said like to entertain the user. However, during the reading, I'll kind of emphasize this point here, that you have to be very specific in that response. So you can't just say to entertain the user. You actually have to say how exactly you're entertaining the user. So you have to say things like to entertain the user by having them collect marbles and see who collects the most marbles, something along those lines. So you can't just simply say to entertain the user. Functionality wise, again, you have to describe what's kind of going on inside of your game. So here I wrote users get points by touching marbles, but their health decreases if they touch a fireball. Now, as far as the input output goes, there are probably many different ways you could do this inside of Roblox Studio. For input, I would write that, hey, I had a proximity detector. When the user pressed like E, then that kind of initiated the fire as well as the marble madness. And the output would be, let's say, the leaderboard showing who got, let's say, the most marbles. So that's like input output. Now, row 2 is using a data structure. In Lua, they have like one data structure called a table, and the table can behave in different ways. Here, we're just kind of using it as, let's say, a list if you're coming from the Python world. They would call this an array, although an array has kind of like different meaning if you're coming from, let's say, the C and C++ and Java world. So this would fulfill the row 2 requirement of data being stored in lists. So I've got the different effects. You might have noticed that the marbles have, let's say, some of them were coming out with smoke, some of them were coming out with the particle emitter, and some of them were coming out with sparkles. I randomly, kind of like when they were being generated, they were randomly getting picked there. In addition, we had the fireball, which I'll show you in a few moments here. And this is very specifically how exactly you were using the data structure as part of your program. Now, row 4 is asking about a function with a parameter. So here I passed in red, green, and blue. You might have noticed that the colors for the marbles were like different here. And inside it would contain an algorithm. The algorithm that I came up with is kind of like this. So again, with if the value of red is greater than 200, I have my conditional here. You might have noticed that the fireball was kind of like shooting in the air like pretty fast. And that's because I created a loop here and I was changing its vector 3 to kind of like shoot out. So the loop was actually sending the fireball higher in the air. So that's how I would take care of the algorithm requirements, the performance task. Other parts of the other parts of the algorithm, let's say I have an else if here. So if the value of red is less than or equal to 100 and blue is greater than 100, actually those balls were actually giving you like a healing effect here, but also creating like a random effect per the array that I showed you earlier. All right, function calls, which is row 6 here. This is how I was calling my function. So I was creating random values from 0 to 255 for red, green, and blue, passing them into marbles. There was actually every time someone initiated it with the proximity detector, it was actually shooting out 100 marbles. These are my examples of 2 different function calls, which triggered different parts of the code that if and that else if to execute. So here I just have like marbles 201, 0, 0, and then I have marbles 50, 100, 0 to take care of row 6 very specifically. All right. So I'm looking at the questions now. So feel free to ask any questions that you have about our curriculum. and also let Jane address some of them too. I think Gino.
Yeah, so let's wait maybe a couple minutes. Oh, yes, we do have a question from Dan. Lua appears to be very Pascal-like. Is this confusing for new programmers? Which is the assumption for CSP?
You know, I honestly don't remember. I don't, you know, I remember doing Pascal way back in the days.
Yes.
So I'm curious, what makes you what makes so Dan, what makes you think it looks like Pascalish? I'm like curious because I actually don't remember now. That was a long time ago, so maybe I tried to forget what Pascal looked like. I think it's like really explicit. Like to me, it looks almost like Python. Again, without the actually, I'll note that instead of Studio, this indentation happens automatically. Like Studio is like really nice. Like it formats the code for you like this. I think almost reminiscent of Python. It's trying to kind of like make you write good looking code. But again, like very specifically, I feel like that the programmers who created this language, like they came up with being very explicit with like if, then, and all over the place. So that is, again, if you're coming from classical programming languages, that's taking the place of like the curlies. And if you have to teach with JavaScript, you know that it's curly brace madness after a while with no enforcement. I think Java's the same way too.
Yep. And then let's move on to the next question from Michael. Do you have a course outline or scope and sequence? Yes. So yeah, Matthew, would you like to share it now, or we can send it by email right after this as a
Yeah,
follow-up?
I think we could send it afterwards. Again, the purpose of our curriculum again is to match what the students have to do very specifically for the computer science principles AP exam, because Studio is extremely complex. I could probably teach like several college semesters on Studio, but at the end of the day, and again, if you teach AP at high school, you know that we have very limited time. You know, I'm starting school this week, but a lot of the country has already started this month. So I think that they have kind of like the heads up on us in the AP world because we're tested at the very beginning of May. And again, with the performance test requirement of 12 hours, like for me, that's like all of April that I have to give the students. So in other words, I have to make sure that I teach all the topics that they need specifically for this programming task by, let's say, the end of March, perhaps. So there's like, I feel like there's never enough time when you're trying to teach things.
Yes. So I guess in a nutshell, we'll send you the sequence and the syllabus after this with the recording of this video. And another question from Dan. Did you say that the College Board is still evaluating the CSP curriculum? Should I answer this?
Yeah, I thought I answered it, but you can.
Yes. So we're under review at this point, and we are working closely with the College Board CSP team so that everything's, you know, good and ready before the closing date for selecting the syllabus. And then Kevin also has a question. I wonder if you still have the Roblox competition in November. Oh, yes. So this one, because we were swamped designing and developing the curriculum, we haven't quite come up with a timeline yet. But yes, we did also have fun evaluating all those great games. So it will happen soon. And Michael has a question. Oh, comment. I used Roblox after the AP exam and students really enjoyed it. Yep, no doubt there. Okay.
Yeah, I'm
So
glad. Studio's
yeah,
like Studio's like super powerful. So like, I think kids can really do a lot with Studio. So I'm glad
Yes.
that they enjoyed and they were able to apply what they learned in Principles to Studio.
Yeah, and if you can maybe spend some time with your students doing some modeling, oh my gosh, they will do crazy things. Okay, so before we wrap up, are there any other questions here? If not, let me just share the link to today's slides. So here is the link. So feel free to keep it. And we also have some free posters. So they're PDFs. So you'll have to download and print them. So there are 3 in there in that folder. And lastly, if you'd like to learn more about what Office provides, here's a brochure for that. And any last words, Matthew?
No, I think I'm good. If you have any questions, feel free to contact us at info@popviz.io.
Yes. So we'll make the course available very soon and send you the instructions on how to get full access. So keep an eye out for our email. All right. Thank you, everybody, and have a great rest of the day.
All right. Bye, everybody.
Bye.